So hey everyone, I'm Alex. Thanks for coming out. I'm a developer at a company in Birmingham, Alabama in the US. It's called Airship. So it's an agency who work with a lot of different types of clients and do a lot of different web and mobile applications. So like I said, we're doing a wide range of applications, and a lot of my emphasis has been on mobile projects. As with a lot of companies, the decision to use React Native was a relatively easy choice because we were already using React on the web, and essentially allowed for our entire development team to learn one central common technology with React and be able to write web and cross-platform mobile applications. So when we first started using React Native, we were pretty blown away by the efficiency it allowed us to iterate on with mobile projects. And again, the development process was it felt extremely familiar to what we were already comfortable with React on the web. However, we soon realized that even though we were able to share a lot of common knowledge between the two platforms, for development, the actual process of getting an application deployed to production was significantly different and just a lot more complex for mobile. So for web deployments, there's obviously a lot of options for you to use based on your needs, but whether you're using something like Heroku, AWS, Netlify, or something more custom to your particular use case. But at the most basic level, though, these types of solutions allow you to set up your application to get it online, get it live within minutes, essentially. However, as I alluded to earlier, mobile deployments require much more consideration and just domain-specific knowledge, more than your average just web deployment. So some high-level considerations for mobile deployments would be like maybe the App Store and Google Play Store releases. So for each store, for iOS and Android, there is essentially just one workflow to actually release that within the App Store and the Google Play Store. Creating production builds. So we need to be building for production rather than development. There's a lot of great tooling built into React Native on the development side, but obviously that doesn't need to make it into the final production build of the application. So code signing. If you've never heard of or experienced code signing with any mobile application, you're a very lucky person. This is probably one of the most difficult aspects of releasing an application. In theory, this particular strategy, or it's a particular strategy that Apple and Google utilize to make sure that each release of an application is created by an authorized individual, but in practice, it gets pretty confusing if you aren't familiar with what it's for and how it works. So, for reference, iOS has something called certificates and provisioning profiles that get pretty confusing, and Android has something called a key store, among other things that go into this process. So there's just a lot of kind of domain-specific pieces there. Device testing. So with the web, we can generally narrow down our browser support to just a few popular browsers to make sure that our web application is running correctly. So we'll test on Chrome, test on Firefox, Edge and whatnot. But with mobile, there are literally thousands of different devices that could be potentially running our application, and each with their own unique set of features and limitations. So making sure all devices are able to run the application is no easy task. So as I mentioned before, with the web, it's relatively easy to just throw a web application somewhere so users can start testing it, maybe in some sort of beta or staging environment. But as you might imagine, simply getting a mobile app for users to test with is surprisingly difficult, especially given the constraints of code signing and the way that Apple and Google control any App Store releases. So having multiple environments, such as staging and production. So related to that user testing, how do we have different environments where users can test? Apple offers a service called TestFlight, and Google has alpha and beta tracks that you can use. However, these take a decent amount of time to actually get a release out so that they can so they can use, and it might not be for every use case. So, creating these different build or types of builds, maybe for like staging and production, can be a difficult thing to manage if they need different environment variables. So like, where are those environment variables coming from, and how do we know what a staging build is versus a production build? And finally, so since React Native is just a native app powered by a JavaScript bundle, some updates could be potentially streamlined over with over-the-air updates rather than a traditional App Store release. So we'll take a look at later on about how that could be possible. So this list isn't all-encompassing, but it does give you a general idea of some items that you have to consider when you're evaluating the solutions we'll go over in just a bit. So before I get into some more automated solutions, here's a quick example walkthrough of some of the steps involved in deploying a standard React Native iOS and Android app manually. So first thing, we have to manually bump up the build and version numbers for iOS and Android. So for iOS, there's something called an info.plist, and you'll just bump up the bundle version number as well as the bundle short version string if you want to create like a new release for the next version. And then you'll do the same sort of thing on the Android side and build.gradle with something called the version code, which is the equivalent of the bundle version for iOS, and then a version name, which is the release number that you see in the Google Play Store. Then we're going to manually change any environment-specific variables. So, maybe for example, you might have something like this in your app where, depending on whether you're running in development or building for production, you just uncomment out the appropriate API URL, for instance. So there could be some more elegant solutions for this, but you just have to remember that React Native apps don't have the same sort of environment that web apps run in. So creating these environment-specific variables, it can be just kind of confusing. Next thing we'll do is create production builds locally and make sure that code signing is set up correctly. So for iOS, we're going to create the production build in Xcode, and for Android, we'll use Android Studio to create that production build. And then, to set up the code signing, I'm just going to show you an example of the iOS side. So this is something you see in Xcode when you set up the provisioning profiles and certificates. So, so maybe for development we need a specific kind of provisioning profile, and maybe for production we need something different, and staging something different there. So we'd have to make sure all that's set up and already configured. Then once we create those builds, we'll manually upload them to each platform. So for iOS, we're going to upload our builds from Xcode, and that's going to send them to something called App Store Connect, and that is just the interface that Apple provides for managing your mobile applications. And then for Android, we'll upload the build in the Google Play console, which is Google's place for managing applications. And then next step, we're going to distribute the build out to any testers, users, so they can test the app before it actually goes into production. So to do that, again, it's different per platform. So for iOS, we're going to use something called test flight. And then for Android, we're going to use either like an alpha or beta track, depending on how you want that to be handled. So one just particular thing about this is that the testing version for Apple can actually take a day or two just to be approved, just the beta version. And just for Android, for Google, it can probably take just that long or maybe longer to just show up in the App Store for any of your alpha or beta testers. So just so you can see how the iteration cycle could be, or the feedback loop could be a little bit slow. And then finally, we'll create and submit a production app. So for iOS, we're just in App Store Connect, we'll create a new release. And with the production build, we set up all the release notes and everything like that, and submit it to Apple for review and release. And then for Android, we can either promote the beta build that we had earlier to production, or we can upload a new build directly to the production track. So all in all, I'd estimate the amount of developer time for this would be somewhere between maybe 2 to 3 hours per release. So you can see how this wouldn't scale very well, especially if you're releasing many versions frequently. So some challenging aspects of that would include everything's going to be manual and takes a significant amount of time for each release. Having different environments is difficult. So basically your only option is to upload a different version to TestFlight and Google Beta, but just kind of designate them as this is the staging version, and then upload something later that is the production version. So it's not very, it doesn't have too much separation between those two environments, essentially. Managing test users is just different per platform. So again, for iOS, we're dealing with TestFlight. For Google, we're using the alpha and beta tracks. And then running any tests, that's going to be a manual process locally, whether it's running unit test or any end-to-end tests that you might have. And then multi-device testing, particularly for Android, just really isn't an option. So there's just too many devices to realistically test everything. So you just kind of have to put a release out there and hope that it's going to work on all these devices. And there are no over-the-air updates. So let's say we have just a very small little bug that is critical, but we need to send out a new update. So for web, we just create a new deployment, send it out, everything's fixed in production immediately. Whereas with mobile, we're going to have to go through that entire process again just to fix that one tiny little typo that was a critical bug. So having some over-the-air updates would be a great thing to have. So luckily, there are a lot of great solutions to automate the majority of these steps and address a lot of the problems that we just talked about. So we're going to talk about 3 particular solutions, and just to say it up front, I'm not really going to tell you which one is best. The right solution depends on your use case and situation. So something that works for our team at Airship, where we're working with many different clients for a shorter period of time, might not be the same for maybe a larger team working on like one product over a long period of time, where you have a very unique workflow that you need. So with that, we'll dive into the first one. So App Center is a all-in-one solution from Microsoft for building, testing, deploying mobile apps, and it also has a lot of additional features built in, such as like push notifications and analytics and crash reporting, among many other things. So I'm presenting this one first because it's probably the most all-in-one solution, although that does come with some significant trade-offs that we'll see in just a second. So the setup process for this is relatively straightforward, where we're just going to create an application in App Center, and it'll connect to our Git repo. And then from there, it can be configured to build particular branches. You can do it on push or just manually. And within these configurations, you can set a number of different options, such as like the Xcode and Node versions that you want it to build with. You can increment the build numbers automatically. You can run unit tests as well as run tests on real devices. They have literally a giant room that has filled with thousands of devices that it'll run your application, and so you can get confirmation that everything is running correctly. You can set environment variables within these configurations. It'll handle the code signing, and it'll also distribute the builds to testers via App Center as opposed to TestFlight and Google Beta. So distributing the builds via App Center to testers allows for a much quicker iteration cycle, and rather than going through TestFlight, where again, it could take a day or two to actually be approved just for beta. So you can create different groups of testers, so you can have as many levels or groups as you want. So you could have like an internal group for testing, and then maybe have an external group for testing, and it really gives you a lot of options there. And App Center can also distribute directly to App Store Connect and Google Play console automatically, so that eliminates the need to do any of that manually. Another great feature is that App Center contains something called Code Push, which allows you to send those over-the-air updates to your React Native application without having to do an App Store release. So that essentially your mobile app is just going to ping the Code Push server, see if there's a new update, and if there is, it'll download that in the background, and then the next time the user starts up the app, it'll have a new, fresh version of the application. So pretty powerful tool there. So although CodePush is bundled with App Center, one of the great things about it is it can actually be used independently without App Center. So it can be used with every other solution that we'll talk about today, or just on its own. And I would just highly recommend having that in every mobile application you build, just for those last-minute bug fixes that seem to always come up, at least for us. So I know a lot of this sounds very great, and it sounds like just this does everything you would want it to do. But there are a few downsides to this approach. So the first being that it's the freemium business model. So Microsoft actually, they have to make money off of this, and so there are different tiers to this service. And you do get about 240 build minutes per month for free, which is not insignificant. You can still do a lot with that, but if you really want to utilize the platform significantly and like run tests and all those things like that, you'll probably want to upgrade that service and get more minutes there. The next thing, the configuration options that we looked at earlier are basically the only options that you have the ability to change. So if you wanted to do something just slightly different than the way App Center handles it, you're pretty much out of luck. All the other options that we'll talk about today have a much more configurable, or they're much more configurable in pretty much every single way. Builds can also be just a bit slow because nothing is cached with App Center. So like node modules and CocoaPods and things like that. So some other solutions we'll look at, they have much more optimized build times. So a good use case for using App Center, you don't have to worry about the smaller details of what you're building, and you're working with a relatively straightforward project setup. Maybe you aren't familiar or comfortable with the pieces involved with native builds and deployments. So I'm not saying that you shouldn't use this if you are familiar with native builds, but it's just in general that knowledge isn't as much of a requirement to use App Center as it is some of the other solutions. And App Center also has great customer service that you can use even at the free level, so they can help you debug certain issues that you might come across. A good use case is going to be if user testing is important. You saw that the distribution aspect of App Center is very powerful and much more streamlined than using something like TestFlight and Google Play. Having both platforms for testing centralized into one workflow for testing is very efficient for managing those beta users, especially if you have someone maybe not as technical trying to manage these users. Giving them one central interface to work with is we've found to be very helpful. So moving on to the next solution. Bitrise is a company that provides a CI/CD solution for mobile apps with a heavy emphasis on React Native. So the setup is relatively similar to App Center, where it'll just connect to your Git repo, and you can configure builds based on the branch. So it also takes care of code signing, environment variables, sending the production builds to Apple and Google and whatnot. So Bitrise is a bit different from App Center, though, because it allows a lot more customization to the workflows for building and deploying the app. So it has an excellent drag and drop editor for you to build a custom solution for your application. And they also have hundreds of integrations with other services for you to use within your workflow. So pretty much anything you can think of that you would want is here, such as like running tests on devices, sending the versions to TestFlight and more. So these integrations can just be dropped into the workflow that we were just looking at earlier. So in general, Bitrise allows you to have much more control over your builds and deployments while still having the support and help from customer service and things like that if you need it. So some downsides to this approach, though, as I kind of alluded to earlier, it also uses a freemium business model. So I think with Bitrise, you get 200 build minutes for free at the free level. Although, like I said, the builds can be a little bit quicker than App Center because of caching if you implement that into your workflow. A basic knowledge of build and deployment sets for a native application would be helpful when creating these workflows. So if you don't really know what you should be doing or what order the steps should happen in, it could be a bit difficult to work with. It also doesn't have a beta testing service built in by default. So it can plug into other services. You can actually plug it into App Center for their distribution if you wanted to, but it just requires a bit more setup and configuration for that. So probably the most common solution would just be using TestFlight and Google Play for that. So a good use case might be you need a slightly unique build and deployment strategy, but still don't have a lot of extra time to worry about the smaller details and issues that might come up. So having the customer support is very helpful, and the UI they provide to manage your apps is very intuitive. You're also maybe somewhat familiar with the steps involved with native builds and deployments. So lastly, I want to talk about a solution called Fastlane. And so Fastlane is a 100% open sourced solution for building and deploying mobile apps, and it has a rich community of plugins that can extend its functionality. So one of the most stark contrasts, as you can see, from this and the other solutions that we talked about, is that Fastlane is simply an open source tool that you can use however you want, rather than a service provided by a company. So because of that, it's one of the most popular solutions out there and has a very large community support and usage. So all the configuration is set up in a file stored in your repo, and in order to build and deploy, all you would need to do is run some simple CLI command based on your specific configuration. So for instance, if I wanted to deploy both iOS and Android, I could run something like Fastlane release to kick off builds and deployments. So here's just a basic example of a very simplified something. It's called a fast file that is the main piece of that. So it would likely be much larger and have a lot more steps involved, but this is to give you an idea of how that's set up. So there are many methods that are available to you by default, such as like increment build number, commit version bump, deliver to TestFlight, et cetera. There's also, like I said, many plugins from the community to extend it, such as running tests, generating App Store screenshots automatically and uploading those. So there's a lot of things you can do to extend this. Fastlane also has a unique approach to the code signing problem with something called Fastlane Match. So essentially, the private keys and certificates that are needed for your application are encrypted and stored in a Git repo, private Git repo, and then Fastlane just pulls this down in order to sign and build your application. It can also automatically update expired certificates with Apple directly, so there would be no need to do any of that manually anymore. It does provide a lot of good solutions, but I'd say it has a few downsides when used on its own. So first thing, you have to run on your local machine. So that could be different depending on who's deploying the application. There's no visual UI to interact with, so everything's just in the terminal and in that fast file. It requires a decent knowledge of the build and deployment steps of a native application. So you definitely want to be at least familiar with what's going on there. And related to that, the match code signing that we just talked about, it can be a bit confusing if you aren't familiar with what it's doing. It does provide a great solution to that problem, but if you don't know what problem it's trying to solve, my experience is that it does make things a little bit more confusing. Environment variables, for staging and production can be a difficult thing to do. There's also, again, no beta testing service built in, so you'll probably have to utilize TestFlight or Google Play for that. So some good use cases of using Fastlane on its own might be you're just an individual working or who needs just a relatively unique workflow to deploy one application to production. And maybe you also don't have any sort of staging beta environments to really account for. So it's not that it can't work with Fastlane, it just becomes a little bit more difficult there. So you might be thinking, though, like we could combine Fastlane with something like Circle CI, which can alleviate a number of the issues that we brought up just a moment ago. So if we were to use Fastlane in Circle CI, we'd have a much better setup for creating different build environment or different environment builds for staging and production. And now we don't have to run the builds locally. It would take place on that CI machine. It can also, Circle CI is also connected to our Git repo, so branches could have a much more custom build configuration there, such as having different deployment targets or utilizing code push to send out updates. All that could be brought into how your fast file is building and sending out updates. So in general, using Circle CI with Fastlane allows you to have a much more customized workflow for your application, and you don't have to use any kind of third-party service or company for that. So a downside of this approach, though, is that it still requires a decent knowledge of builds and deployment steps for a native app, as well as being familiar with Circle CI. But again, it does resolve some of the issues with using Fastlane just on its own. So maybe a good use case for this is you're a team with maybe someone knowledgeable on mobile apps working on one or a small number of applications. And you also just need more granular control over the build and deployment steps in every aspect. So as you can tell, there are a few different approaches to deploying React Native that definitely have some pros and cons to each. I hope this talk didn't scare you off from actually wanting to deploy a mobile application, but the intent was to inform you on the options available to you. So we obviously couldn't cover any of the solutions in much detail at all, so I would suggest digging into any of the options I presented today that piqued your interest. So I've spent a decent amount of time with these solutions, so you can please find me afterwards to talk, and if you have any very specific questions that you want to go over. So here's a link to all the slides I presented today, and there's my Twitter and GitHub handle if you want to reach out. But that's it, so thank you very much.
Thank you very much. So do we have any questions? Nice and close. Yeah, you mentioned Circle CI. Are there specific services as part of Circle CI that you need to use with Fastlane, or can you use any other kind of software as a service CI provider?
You can use other ones. I mentioned that specifically just because they have a really good kind of Mac setup, and the building mobile applications is, I felt like, in my experience, it works really well with Circle CI, but I know people who use Jenkins or something else of that nature, so it really could be any of those solutions, depending on how familiar or comfortable you are with them. Yeah.
Any more questions for Alex? Talk amongst yourselves.
You talked about code push as part of Microsoft App Center. To what extent can code push actually push out code to your apps? Is it more than just a config file, or can actually push out binary data? Because I know like Apple and Google actually prevents and forbids a lot of that. So if they see you doing something that they don't like, they can boot you off the store. So how does code push fit in all that?
Yeah, so I think when code push came out, which was, I guess, I don't know how many years ago, there was some pretty strong backlash from Google and Apple on applications that used that. And I think initially you saw some applications get denied because it contained code push. They've recently backed off considerably on that, so I haven't heard of any application getting rejected because code push is in there. It's in every single application that we've built for 3 years, so it's definitely okay to use. They did, I think Apple has put out some guidelines on how to use it, where basically if there's any like significant updates to the application, like in terms of like large UI changes or large features that are added, they recommend going through an App Store release. And honestly, I would recommend doing that as well, just so that the fresh download that a user gets when they download from the App Store is the build that you want it to be, without having to like fetch that code and download it after it's downloaded from the App Store. So with that said, that's kind of just generally around like the Apple and Google. How it actually works, so your application, when it boots up, it's going to check the code push server and see if there's a JavaScript bundle. And with React Native, we have a native app but then there's also a JavaScript bundle that's bundled with your code, and that's kind of what's powering everything. But it is just, at its core, just a JavaScript bundle. So code push in your application can download that from a server and just replace the one that you have locally, and that'll be the new logic for your application to run everything. So the limitations with that, though, are obviously the native app side. With React Native, you have the native and the JavaScript. The native side doesn't change, and so maybe you put out an update that, or you upgrade a package that has native code, like maybe like a calendar library that is like accessing the native calendar events. If you were to code push an update that updated that and was trying to use like a new method for that library, the native side of that wouldn't be updated. So the JavaScript would fail. Luckily, code push does have like a fallback, a pretty seamless fallback of it keeps that around the previous build. So if something does fail on a code push update, it'll just revert back to the previous build, so the user won't really see anything. But yeah.
Do you have some more questions for Alex? I shouldn't really stand behind a pillar, should I? Any more? All right. Well, thank you very much, Alex.
Yep. Thank you.
So we'll be back here in 5 minutes. Amir, who's a senior software engineer at Cypress, is going to be talking about end-to-end testing with Cypress. So don't go anywhere.